Select the reaction mechanism that best describes how hydrobromic acid reacts with ethanol. So in drawing reaction mechanisms, we are drawing curved arrows that show how electrons flow in the reaction. In other words, they're going to show us how bonds form and how bonds break. So when we draw our curved arrows for our reaction mechanisms, they always indicate the flow of electrons. And the arrow always it originates with the electron donor. So saying this is the electrons that are moving, and it ends with the electron acceptor. And so in an acid-base reaction, the electron donor is the base and the electron acceptor is the acid. So we see that we have hydrobromic acid, so this is clearly the acid or electron acceptor in this reaction. And we're reacting this with ethanol. So ethanol is a simple alcohol. Its reactivity is quite similar to water. And like water, these simple small alcohols can be amphoteric. They can act as either an acid or as a base. Because we're reacting this with a strong acid, we know that the ethanol is going to act as a base, which means that it will be acting as the electron donor in this reaction. So on the ethanol, it is the oxygen that is the electron donor. So if we'll redraw this ethanol here. So here is our electrons that are going to be donated. This is where we're going to start our first curved arrow. And if we're reacting this with hydrobromic acid, there's our hydrobromic acid. So we have a hydrogen that's attached to bromine. So bromine is electronegative. It's also a large atom that can easily accept a lone pair of electrons. So this hydrogen that's attached to the bromine has a partial positive charge. And so that means this can act as an electron acceptor. So we can draw the first curved arrow from the lone pair of electrons on the oxygen to that hydrogen, which can act as an electron acceptor. So we are forming a new bond from this oxygen to this hydrogen. This lone pair of electrons will no longer be localized on the hydrogen. They will be shared as a covalent bond between the hydrogen and the oxygen. And now hydrogen can only have one covalent bond. So when we form this new bond, we need to break the hydrogen-bromine bond. And when we do that, we give the electrons from that bond to the bromine. So we are forming a molecule of protonated ethanol. So here is where we have formed this new bond between oxygen and hydrogen, which means that this oxygen now has a positive charge. And this is the conjugate acid. So if ethanol is acting as a base, it's accepting a hydrogen to form the conjugate acid. And then the bromide ion that is being formed is the conjugate base in this reaction. Okay, so we can label these. We have an acid, we have a base, we have the conjugate acid, and the conjugate base. And so this question was simply asking us about the proper electron flow. So we are looking for the mechanism that has the electrons originating on the oxygen of the ethanol, flowing towards the hydrogen of the hydrobromic acid, and then breaking the hydrogen-bromine bond. And that's what we see here in B.